Hi, today we learned about the negative and zero rules of exponents. That's two different rules, and we're going to talk about both of them. So first we started class with bell work. This is reviewing some stuff you've already learned. So here means we have three x's, x times x times x, and here it means we have four x's, x times x times x times x. So altogether we have 7. So we know the quick method instead of counting would have been just to add 3 plus 4 equals 7. So our new exponent is x to the 7th power. Okay, this one was a little bit of a thinker problem, but we learned that when you've got what's called a quotient, looks like a fraction line, it means divide, then we subtract b minus 3. So b minus 3 has to equal 8, which really just means like what minus 3 equals 8? Well, we could just do 8, 9, 10, 11. 11 minus 3 equals 8, so b has to equal 11. So this would be like y to the 11 over y to the 3, and we would subtract 11 minus 3 equals 8. And then the last one, write the expression as a single positive exponent. Well, oh man, I'm making it tricky, huh? We've learned that we multiply these two together, but you can't actually multiply a times 5. It just stays as a5, or we more traditionally write it with the number first and the letter second. So z to the power of 5a. That's how we would do that. Then it was a little bit different. We didn't jump into our notebook and write down a goal. We looked at some facts about exponents. So 4 to the power of 3 means 4 times 4 times 4. I think that's like 64. And then 4 squared means 4 times 4 is 16. 4 to the power of 1 just means 4. Then 4 to the power of 0, we have not learned about that yet. That's one of the things we're learning today. But when you type it in your calculator, you're going to see that it equals the number 1. And we'll talk about why in just a minute. And then here, when you type this in your calculator, you're going to see that it equals 1 over 4. And then 4 to the negative 2, you're going to see equals 1 over 16. And then 4 to the negative 3, you're going to see equals 1 over 64, even though you can't read that very well. So I want you to look at specifically these two. 4 squared equals 16, and 4 to the negative 2 equals 1 over 16. Okay? We're learning about two rules today, the negative rule and the zero rule. So let's see what it has us learn about first. What did you notice about the number with the exponent 1? Well, the exponent 1 just was a 4. What about the number with the exponent 0? It equaled a 1. What did you notice about the numbers with the negative exponents? Okay, let's go back and take a look. Remember those two I pointed at? Like, that's a 16 and that's a 1 over 16. That's interesting. The one that had a negative 1 versus a positive 1, it was a 4 and a 1 over 4. Let's look at the first and last one. 4 to the positive 3 was 64, but 4 to the negative 3 was 1 over 64. Okay, so you're kind of thinking to yourself, hopefully as you watch this, like, oh, I'm noticing some of those numbers are similar to each other, positive or negative. Okay, so now the question is, like, make a prediction. If we knew that 4 squared equaled 16, and that 4 to the negative squared equaled 1 over 16, that's negative being the only difference here, then the determination was make a prediction of what would x to the negative 2 look like when we simplified it. Well, x squared would just be a normal thing. What happens when we made this negative? It became a fraction. So x to the negative 2 becomes a fraction. Okay? So, here I have it now all typed out, and you had a discussion with your team. Now we can look at our notebooks at page 11, I think. First goal, I can simplify exponents using the negative rule. Okay, you've made a prediction, well, I told you because in this video, right, that it turned it into a fraction. And that's what it does. X to the negative 5 becomes 1 over x to the 5. The negative exponent just means make it a fraction. That's all. It means take the base that is attached to the exponent and move it to the bottom of the fraction line. So right here, this 5, it's not attached to the exponent, so it's not what we grab. We only grab the base that is attached to the exponent, and move it to the bottom of the fraction. So like here, the x to the negative 5, x is the base, negative 5 is the exponent. Because this base is attached to the exponent, we move to the bottom. Well, that would leave us with just like a blank top. Well, we don't have that. We don't do that. So we always put that 1 on top. The reason is because there's an invisible multiplied by 1 always in front. But like we never write it down. That would be ridiculous. But when we move this down, that 1 is still left there. Now here we're going to see we can use some rules we've learned before in combination with the negative rule. So when we have this multiplication sign, that tells us we can add our exponents together. 4 plus negative 10 equals negative 6. And then we can move it to the bottom of the fraction. Okay, so page 11 in your notebook. And we worked on our negative rule. In fact, I'm noticing in this PowerPoint I forgot to add something, and that is when you have the negative rule, there's this phrase we use, and it is cross the line and change the sign. Cross the line and change the sign. Cross the line and change the sign. So cross the line means cross the fraction line. We move to the other side of the fraction line. And change the sign means, well, this was a negative exponent. Because we crossed the fraction line, because we moved it to the bottom of the fraction, it's now a positive exponent. So cross the line means move it to the other side of the fraction line. And then change the sign means if it was negative, make it positive. If you're doing some crazy stuff, I guess if it was positive, now make it negative, if for some reason you're doing that. Okay, so then page 11 in your notebook is what you would have worked on. And let's go take a look at page 11 in the notebook. Oh, sorry, pause for a minute. It looks like I don't have it open yet. Let's go open it now. You can fast forward this if you want to. Because I do want to look at it and help you as needed. Okay, so here's page 11 in our notebook. And our goal, I can simplify exponents using the negative rule of exponents, right? I can simplify exponents using the negative rule. And you can write that down. And then here's an example of what we learned. And then right here in this little nice little wavy thing is where you're going to write cross the line and change the sign. Cross the line and change the sign. There we go. And then we saw some examples that we already looked at in this on the PowerPoint. And now you did some practice with your team. So I started with a basic one. Here's the base, is the x, to the power of negative 4. So there's our base connected to a negative exponent. So we have to move it to the bottom of the fraction. So we've crossed the line, and now we change the sign to be a positive 4. Now we can't actually leave that top blank. Remember, there's always that invisible multiplied by 1 in front. We just don't write it because that would be silly. So that got left up there. So we put that there. Okay, y to the negative 13, same thing. Let's cross the line and change the sign. So now it's on the bottom of the fraction and it's a positive 13. And we put that 1 on top. Okay, here we've got to do a little bit of work first. We know when we have multiplication, it means we're allowed to add the exponents. 3 plus negative 8 is z to the power of negative 5, but it always wants us to simplify to a single positive exponent. So we're going to cross the line and change the sign. Move it to the bottom of the fraction and make it a positive 5. Put that 1 on top. Okay, when we have that divide symbol, it means subtract. 7 minus 12, so 7 minus 12. Notice how it's not 12 minus 7, but 7 minus 12. So 7, 8, 9, 10, 11, 12. It's a 5. Man, I use 5 a lot. 4 to the power of negative 5. And then we need to cross the line and change the sign. Because 4 is the base, I'm taking the 4 with me. Remember this example we did on the PowerPoint where 5 is not the base, so it just stayed where it was. W was the base that we took here. Well, now 4 is the base because it does have the exponent, so we take it with us. It's stays as a 4. So we've crossed the line, and now we change the sign of that exponent, and of course we put a 1 on top because we can't just leave it as it is. Okay, now we're learning two things. That was our negative rule. Now we're going to learn about the 0 rule of exponents. Let's just move to the next slide. Remember this, and we've already looked at negatives. Now we know a negative means turn it into a fraction. Move this to the bottom of a fraction, right? The exponent, another way to think of this, these positive ones we've talked about before, is this tells us how many 4s to write. Here I'm going to write 4 3 times. Okay? And let's make sure I got this out. So that'd be like 4 times 4 times 4. Well, just like we mentioned before, there's always that invisible 1 in front. We just don't write it because that'd be silly. Okay, here there's 2 of them, so 4 times 4. There's that invisible 1 always out there in front. We just don't write it. Here we just write one of the 4s, but again, there's always that invisible 1 out front. This means write none of the 4s. Don't write any 4s. But what's still always out in front? That invisible 1. So here's kind of that pattern. There's always that 1 in front, and then the amount of 4s is shrinking until we got to 0. And then the negative we know means, okay, now we've got that many 4s, but now they're on the bottom of the fraction. So anything to the 0 power equals 1. So y to the 0 power means I'm going to write the letter y 0 times, so I just have the 1. 4 to the 0 power, I write the number 4 0 times, so it just equals the number 1. A little bit trickier. The 5, there's a 5 again, I use 5 a lot. The 5 does not have an exponent, so we don't do anything with it. It's the w that has an exponent. We write the letter w 0 times. Yeah? Now, what I've shown here is kind of an extra step you can think of is I wrote the letter W 0 times, but there's always a 1 out in front, so you could write that 1. Or you can just think of, I write the W 0 times, so the only thing that's left is a 5, because we don't have to worry about that one invisible 1 that's out in front. Either way, the answer there is just 5. And here, we can use one of our rules, because we've got multiplication. That means we're allowed to add the exponents. 4 plus negative 4 is 0. That means I write the letter A 0 times, and I have a 1. Okay, and let's just go look really fast at the notebook for that. 0 rule. And here in the notebook, we got a nice little squiggly thing, and we're going to write anything to the 0 power equals 1. Anything to the 0 power equals 1. There we go. All right, those are the examples we already talked about, and then as a team, you guys would have worked on this. G to the power of 0 is just 1. Yeah, we still can write that. Because I'm writing G 0 times, so I just have that 1. H, I'm writing it 0 times, so I just have that 1. I have to do a little extra work. I multiply, which means I add together. 6 plus negative 6 is J to the 0, which means I write J 0 times, I just have that 1. The divide means subtract. 5 minus 5 is 0. Anything to the 0 power equals 1. And of course I had to make it a little more difficult down here. 3 does not have an exponent. So now it's just m to the 0, means I don't write m at all, so I just have that 3 left over. And then another rule we learned, when they're squished together like this, it's a power to another power. We multiply. 3 times 0 equals 0. Anything to the 0 power equals 1. Then we can go do our exit ticket, which I definitely gave you some challenging stuff here on this exit ticket, huh? And let's talk about how to do these. So here, the 3 does not have an exponent, so it just stays put. X to the negative 2, what do we do with that negative? Cross the line and change the sign. We move it to the bottom of the fraction. So X, we cross the line, we change the sign. It was a negative 2, now it's a positive 2. But the 3 we did nothing with, so the 3 just stayed put. So we didn't have to worry about putting a 1 on top. Okay, explain and complete sentences. How do you simplify expressions with a negative exponent? Cross the line and change the sign. I would be fine with that. Or you could have been more clear about a base that has a negative exponent moves to the opposite side of the fraction line, leaving either a number behind or the number 1. Extend your thinking. What value of b makes this equation true? Okay, somehow we have to make it equal 1. Well, what is the thing, like what's the exponent that makes things all just magically turn into 1? 0 is that exponent. So we've got divide means we're going to subtract 5 minus what equals 0. 5 minus b. 5 minus what equals 0? Well, 5 minus 5. So we know that b equals 5 because we do 5 minus 5 is 0. Well, y to the 0 power means write the letter y 0 times, so we have the number 1. Okay, that's what we learned about today. You guys are awesome. Have a great day.